we have our hand trick for sine and cosine. It's the square root of the number of fingers over 2. So for sine of 30, 30 is the top, so radical 1 over 2, or 1/2. Cosine of 45, so cosine is the bottom, so radical 2 over 2. Tangent is square root of the top over square root of the bottom, so radical 1 over radical 3, which turns into radical 3 over 3. Cosine of 60, so cosine is the bottom, so radical 1 over 2, so 1/2. Tangent, radical 3 over radical 1 is radical 3. Sine of 90, so if I fold in my 90, sine is square root of the top over 2, so radical 4 over 2 is 1. Then when we get into these, what do we have to think about?
That number minus 1.
So this is in quadrant 2. In quadrant 2 is sine positive or negative? Positive. Reference angle 180 minus 120 is 60. So sine of 60 is radical 3 over 2. 135 is quadrant 2. 180 minus 135 is 45. In quadrant 2 is tangent positive or negative? Negative. Then square root of the top over square root of the bottom, so radical 2 over radical 2 is 1. 150 is quadrant 2. 180 minus 150 is 30. In quadrant 2, cosine is negative. Cosine of 30, radical 3 over 2. What quadrant is 240 in? Secant is the reciprocal of cosine. So 240 minus 180 is 60. Cosine of 60 is 1/2. So secant would be 2, and in the third quadrant that would be a negative. 270, you can think about right here. That's the point 0, -1. Sine is the y. Cosecant is the reciprocal of that, so reciprocal of -1 is negative. And 330 is quadrant 4. 360 minus 330 is 30. In quadrant 4, tangent and cotangent are negative. Tangent of 30 is radical 1 over radical 3, so cotangent would flip it, radical 3 over radical 1, so negative radical 3. Are we okay on that review? So we're going to look at the double angle identities. I like to start out here just kind of showing you where these double angle identities come from. So I'm going to prove one of them for you. You don't necessarily have to write this down. I'm not going to ask you to prove it, but I just want you to recognize it's really just derived from the angle sum identities that we just got done doing. So for instance, if I said cosine of 2a, 2a is the same as a plus a, right? So look at your flip chart for the cosine sum identity. So cosine of a plus b. What is that formula?
Cosine of A cosine B minus sine of cosine B.
Okay, since both angles are a, what is cosine a times cosine a? Sine a times sine a. Plus cosine squared plus sine squared is 1, but minus is not. So these double angles, we really wouldn't even have to have these formulas. They come from the sum identities, but if you just rewrite that sum identity, this is what it turns into. The cosine sum identity actually has a few different formulas, because if I take this cosine squared minus sine squared, well, cosine squared is 1 minus sine squared, right? From that main Pythagorean identity we've used over and over again. And negative sine squared a and negative sine squared a would be -2 sine squared a. Or I could replace sine squared. So if I replace this, sine squared a is 1 minus cosine squared a. You distribute that negative, you have cosine squared plus cosine squared, so 2 cosine squared a minus 1. So the cosine double angle actually turns into 3 different options. I could do the same thing to prove sine and tangent, but I'm not going to for the sake of time. So there are 5 formulas for you to write down on this double angle page. And all of these are provided on the formula sheet. All right, so I have lots of examples here. We'll do as many as we need. So basically there's a few different types. I think for every one that I put up here, I have like an A, B, and C. If you guys are good after A, I'll move on. If we're not, then I'll do B and C. Okay, so you guys just tell me. So here is our first one. Sine of theta is 8/17. Cosine theta is less than 0. I need to find sine, cosine, and tangent of 2 theta. Okay. So we have to kind of look at our starting point. If I need sine 2 theta, I only have one formula option for that. Sine 2 theta is 2 sine theta cosine theta. My sine theta is 8/17, but do I know cosine of regular theta? No. But we did problems like this back in chapters 1 and 2. So we have to figure out what cosine is, cosine of regular theta, so we can plug it into our formula. We've done this a few different ways. I think the most popular way was drawing triangles. Sine is positive, so that means it's either quadrant 1 or 2. But cosine is negative, so which quadrant are we in? Quadrant 2. So if you drew your triangle in quadrant 2, think back to SOHCAHTOA. Sine is opposite over hypotenuse. So this side would be 8, this side would be 17. How would I find my third side? 8 squared plus b squared equals 17 squared. So this is pulling in, not something new because we have done it, but it's been a while. When I do a square root, we have to do plus or minus. How do I know if it's positive or negative? Yeah, if you're going in this quadrant, your x would be a negative. Square root of 225 is 15. So this side is negative 15. So now you can tell me cosine of theta. Cosine is adjacent over hypotenuse, so negative 15/17. So then we just multiply. So we get negative 240 over 289.
How'd you get negative 15/17? I guess that part.
SOHCAHTOA. I'm trying to get cosine. So cosine is adjacent over hypotenuse. So from here, my adjacent side, adjacent means touching, so that's 15, and my hypotenuse was 17.
Why is the square root of 225 negative 15?
When you add a square root, it's positive or negative. You have to pick the positive or negative based on your quadrant. So if you're in this quadrant, you go backwards 15, so your x would have to be a negative. Other questions? I also asked for cosine 2 theta. We have 3 different formula options for this one. We can use any of those 3 formulas. So which one do you want to use?
One minus 2 sine squared, because we already have
So we can, since we already went through all the work of doing the triangle, we could have done any of them. But if I hadn't had to draw my triangle to find my sine 2a, this formula would have been definitely the easiest. So 1 minus 2. Sine theta, I told you, was 8/17 squared. And so just plug that in. What does that equal? Thank you. All right. Tangent. How do I get that?
2 tangent A minus 1 minus tangent squared.
So tangent of theta, tangent of my original. So tangent is TOA, opposite over adjacent, so 8/-15. If you put this all in parentheses at once, or in the calculator at once, make sure you put parentheses around the bottom. I've got negative 248 over 160. There's a second way we could have gotten tangent. Tangent is sine over cosine, right? Since we'd already found sine 2a or 2 theta and cosine 2 theta, you could have just divided those. Sine 2 theta was part A, divided by cosine theta was part B. You can plug that in your calculator, or if you multiply by 289 on top and bottom, you get negative 240 over 161. So same thing. If you have sine and cosine, it's probably faster just to divide them. But if you don't, you'll have to go with the formula. All right. Do we need another one like that? Okay, let's do that. All right, so this time I'm going to tell you cosine is 3/5 and sine is less than 0. I want sine, cosine, and tangent of 2 theta. I like to always write out the formula I'm using. So I can see to find sine 2 theta, I have to know the sine of theta and the cosine of theta. I currently know the cosine of theta. How will I get the sine of theta? Triangle. Okay. Cosine was positive. If you think all students take calculus, that's quadrant 1 or quadrant 4. But sine is negative, so it would have to be in quadrant 4. SOHCAHTOA, cosine is adjacent over hypotenuse. So this would be a 3 and a 5. Pythagorean theorem. Would this be a positive or a negative? It's like your y, it went down. Yeah. So our missing side is negative. If you didn't catch the negative there, you could always, after you did your sign, realize it had to be negative and just throw a negative on there. So sine, opposite over hypotenuse, so negative 4 over 5. So if you multiply, you get negative 24 over 25. A little more involved, but it's really just pulling in stuff that we haven't done in a while. We have used it before, and now you just have to plug it into a formula. How could I find cosine 2 theta?
Use the formula to cosine squared theta minus 1.
So cosine of theta is 3/5. So if we put that in our calculator, I think you get negative 7 over 25. What would be the easiest way to find tangent?
Sine of cosine.
Mm-hmm. So negative 24 over 25 divided by negative 7 over 25. So you could put that in your calculator. You could just multiply by 25 on top and bottom. So negative 24 over negative 7, or positive 24 over 24 over 7. So I want to find sine of theta and cosine of theta. And this time I'm telling you what cosine of 2 theta equals. So what I look at when I start these problems, if I see a 2 theta anywhere, that tells me a double angle. So I'm looking at my double angle formulas. I see a cosine 2 theta. So I go to those, there's 3 options. I prefer to use formulas that only have one trig function in them at a time. They generally turn out a little bit easier to work with. So I'm going to pick one of those. So let's just say I say cosine 2 theta equals 2 cosine squared theta minus 1. Okay, it's not the only way to do it. I just picked one of my 3 formulas to start with. When I go to plug in, what do I know this time? So I can replace this with a 2/3. Now, if I were trying to solve that for theta, what would I do? Add our 1 over. So 2/3 plus 1 is 5/3. Then what do we need to do? So 5/3 divided by 2 is 5/6. How do I get rid of a square? Okay. When you add a square root, you do a plus and a minus. We have to figure out which one it is. I told you that theta was between 90 and 180. What quadrant is that? In the second quadrant is cosine, positive or negative? Okay, so we have a negative. This is like radical 5 over radical 6, but we know we can't leave the radical on the bottom. So multiply by your radical 6, so we get radical 30 over 6. Okay, so we just use the formula in reverse this time. I found cosine theta, I also need sine theta. We have 2 options. We could do the same thing that we just got done doing, except pick the formula that has sine in it. So do the 1 minus 2 sine squared theta and solve for sine. Or we can start it like we did the other two problems where we set up a triangle and go from there. So which way do you guys want to do it? Triangle?
Okay, I'm gonna get lost though before you do
Okay.
that. How'd you get multiplied by square root of 6/6?
So I just broke this radical up and put it on top and bottom, but you can't leave a radical on the bottom, so I just multiplied by what was down there.
Okay.
If it had been like a square root of 2, I would have multiplied top and bottom by 2.
Okay, I see that.
So we already know we're in the second quadrant. So if you drew your triangle. Here's cosine. Cosine is adjacent over hypotenuse. So if you want your other side, you have to do Pythagorean theorem. A squared plus b squared equals c squared. Solving for b. You have to do a square root, plus and minus. But if you're thinking about the second quadrant, the vertical side it went up, so it would be a positive radical 6. So sine is opposite over hypotenuse, so radical 6 over 6. So we know on the proofs, we try to box in the easier side. Which side looks easier? Let's box in right. So on the left, I don't have any formulas for cosine to the 4th. But we have a minus. These are both perfect squares. We could factor this using a difference of squares. One goes to plus, one goes to minus. Cosine to the 4th would break into what? And sine to the 4th would break into? What is cosine squared plus sine squared? What is cosine squared minus sine squared? Cosine 2 beta. It was the first of our identities. We had this side, so it's cosine of 2 times that angle. And 1 times that would just be cosine 2 beta, which is what we want. Yeah, the proofs are easier than the solving on these. Do you want to do another proof? Or do we think we've got it? One more. Which side would we box in? Cotangent x. What can you change cotangent into? Let's do cosine. It is 1 over tangent as well. But if I look at my goal, we don't have any tangents there, so let's just go to cosines and sines. Sine 2x. So you're looking at your sine double angle formula, and that turns into what?
2 sine x cosine x.
All right. So if we multiply these, this is just over 1. You multiply the tops, you get 2 sine x cosine squared x. The bottom is just sine x. What happens? Okay. Look at where we're going. Do you know how to get there from here?
Can you do the differences?
So this is an x and that's a 2x. If we get stuck, we know we can work the other side, right?
Can't you just isn't that just, doesn't that equal it if you were to add one to the other?
Okay.
Well, there's one right here, whatever, and it's cosine squared, cosine 2a equals 2 cosine squared a minus 1. So
Okay. You're right. So this would be the same as 2 cosine squared x minus 1 and plus 1, right? If I add and subtract 1, that turns into 0. This part is cosine 2x, and then we have a plus 1 on that. And we got it. I'm going to do one last problem, I think. So I am going to give you an expression, and I want to simplify this as much as possible. So 2 cosine squared 5x minus 1. What does this look like? We have 2 cosine squared minus 1. Yeah, I gave you the right hand side of the formula. So my A in this case is the 5x. So this is the cosine 2a formula. A is our angle, which is 5x. So we get cosine 10x. And that's as far as we can simplify it. B. Sine times cosine. That doesn't match anything exactly, but what's it close to? Except it's just this part. So if you didn't want the 2, you would have to move it over to the other side, right? So it's like 1/2 sine 2a. If I just manipulated my formula a little bit. So what's my A here? What's 2 times 165? 2 times 165?
330.
Can we evaluate that, the sine of 330? Yeah. That's in quadrant 4. Reference angle, 360 minus 330 is 30. Quadrant 4, sine is negative. Sine of 30 is 1/2. So this turns into negative 1/4. So we just have to be able to manipulate these formulas if I give you the other side. no, we don't have much